Okay, so now let's take a look at this question. Leetcode 876 to find the middle point of a linked list. So first, let's take a look at the what the question is. In this question, we are given the head node of a linked list as the input. So the input is the head uh, node of a linked list. So the output we need to give the middle node of the linked list. So there are two cases. When there are odd number of nodes in the linked list, so it's quite obvious, so we just return the middle one. And then when there are even number of nodes, we are asked to return the second mid node. For example, we have 1, 2. Let's do it this way. 2, 3, 4. So in this case, there are two middle points, 2 and 3, and we should return 3 in this case. Okay, let's look at a few more examples. For example, if it's 1, 2, 3, 4, we should return 3. If it's 1, 2, 3, 4, 5, and then we should return 3. Okay. So how do we solve this problem? Approaches. First way, very straightforward way. Method number 1. A very straightforward way is to count how many nodes are there in the list, and then we run through the list a second time, and then we can find out the mid list. Okay, count total number of nodes, go through the list for the second time, and then return the mid node. So in this case, the issue is that we need to go through the list twice. So is there a way that we can just go through the list once? Okay, talk about the method number 2. So in this method, we can define 2 pointers, a slow pointer and a faster pointer. And then for the slow pointer, we move 1 node at a time, and for the faster node, we move 2 nodes at a time. And when the fast pointer reach to the end of the linked list, the slow pointer points to the middle of the linked list. We can go through an example here. For example, let's use this one. Okay, so we have the slow pointer, we have the fast pointer. They all point to the head at the beginning. And then for the first step, okay, slow pointer moves to here, and then fast pointer moves to here. And then so the fast pointer is not pointing to the end, and then we should keep moving. So in the second iteration, fast pointer move to the end. Okay, if returns null, and then here is here the slow point to 3 at this time. So it's exactly what we want. Let's take a look at this example. Okay. Slow, fast. Okay, first step, S goes to here, and then fast goes to here. Okay, and then the second step, fast goes to 5, and then S goes to 3. So then we find out, okay, the next point, the next node of the F is null, so fast should not move forward anyway, so we should return S at this time. So now what is the time and space complexity? Time, as we go through the iterate each node of once, so it's O(n), and space, we're not using any extra space, so it is O1. Okay, so now let's start to do the coding. Okay, public is not middle not is not head. So first check the corner case. If head is equal to null or head.next is equal to null, in this case we just return the head itself. Head. Okay, so this node slow is equal to head. Okay. And then while, let's check, fast is not equal to null. Slow is equal to slow.next. So we, as we mentioned, fast.next is not equal to null, so we can do fast.next and .next. So we will not get NP here. And at the end, we just return slow. Okay, let's think about this. In this question, when there are even number of nodes, we need to return the second node. What if we need to return the first node? Okay, let's discuss here. Discussion. What if we need to return the first node when there are even number of nodes in the list? Actually, it's pretty simple. One quick way we can do that is to just make one change here. Make a fast equal to head.next here. Why the case? We can, let's take a look at the example. Okay. Okay. Oh, we don't need this one. Okay. So first, slow point to the head and the fast point to head.next. Okay, and then in the first step, fast point to 4, and then slow point to 2. Now fast.next is now, in this case it will not move forward anyway, so S is pointing to 2, and then we are returning the first one of the mid node. What about the other one? Let's just double check. Okay. Okay, so fast is pointing to 2 at the beginning. Okay, so fast is equal move to 4 at this time, and then s is moving to 2. Okay, and then fast is not equal to null, fast dot next is not equal to null, and so fast will move forward twice, and then s will move forward once. So s is pointing to 3. Okay, still correct. So we see that just by doing this change, we can return the first node if there are 2 middle nodes. Okay, that's all.